Hello students and welcome to this calculus lesson. In this video, we're going to start to learn about slope fields. We're going to learn what they look like and why we use them. So let's get started. At its most basic level, a slope field is just a pictorial representation of all the possible solutions that could exist. So this could be very useful, especially in the time of computers that we're in, of taking a look of what a solution should be before we actually find a solution for a differential equation. So just keep in mind that differential equations are the first derivative, and when we're given a derivative, a differential equation, and we want to go up, remember that there are an infinite number of solutions that we could find. So for example, let's take this one that we've been working on. We want to separate these variables. So I'm going to say, okay, we have dy here equals x plus 3 dx. And what do we want to do with that? Well, in our previous videos, we were integrating. And when we integrate this, we're going to get y equals x squared on 2 plus 3x plus c. And we could say f of x equals x squared on 2 plus 3x plus c. And what you want to see here is that c. This is the general solution. Without an initial value, we have to assume that every solution could exist. This could be plus e, plus 8, minus 100. It could be literally any number for that plus c. And so what this is going to represent is all the possible parabolas that could exist for the original function for f of x, because any of those derivatives will get us x plus 3. So on the AP exam, you're going to be expected to do several things. The first thing that you're going to need to be able to do is to sketch a slope field when you're given a differential equation. We're going to look at how you actually do this and what it looks like in just a moment. The second thing that you're going to want to be able to do is, given a slope field, you're going to want to be able to draw a particular solution that goes through a particular point. Now, when it comes to some AP multiple choice questions, one of the things that you might be asked to do is to match a slope field to a given differential equation. Something like, okay, here's the differential, here's dy dx. Which of these possible answer choices, A, B, C, or D, will actually match that differential? And then the final thing that you might be asked to do on an AP exam is to match the slope field to the solution of a differential. So, okay, we've already solved for the differential. We know what f of x is. Which of these could have been the slope field given? All right, so we've been talking about slope fields this entire time. Now let's actually learn, okay, what are they supposed to look like? So a slope field here is going to be, and this is what you're gonna have to do on the AP exam, is it's gonna look like basically a graph, okay? And there's gonna be a bunch of little dots on here. This is our differential. We have dy dx equals x minus 1. All you have to do to create a slope field is to figure out what are the slopes at each of these points. So for example, if I want to take this point, -2, +3 right here, then I'm going to substitute in -2 for x and +3 for y. Now there's no y here, but so I'm going to take this point, -2, 3. I have an x value, so I'm going to get -2 minus 1, and I'm going to get -3. And what I'm going to do is I'm going to, okay, say this is the slope at -2, -3. So I'm going to sketch in a little line that has a pretty good estimate of what a slope of -3 would look like. So something like that. Now I'm going to find another one here where maybe I could do -1, 3. Okay, so here's -1, 3. That's the next one I'm going to look at. And again, I don't have a y value. If I did, I would also substitute in the y value, but I have -1 minus 1, which gets me -2. So that's not going to be as steep as the -3 that I just put down. So, but it's still going to be negative. So maybe something like that. And you can see, okay, I've taken out some of the steepness, but it's still negative. So keep going across this top row. Let's try 0, 3. So I'm looking here at this point. So 0, 3, I'm going to substitute 0 and get -1, and I'm going to get -1 here. So -1 slope, just a little hash mark, kind of looks like that. So let's look at our next one, 1, 3. And if I put in a 1 here, I get 1 minus 1, and it's a slope of 0. So I'm going to put in just a flat line. And then lastly, I'm just going to talk it out, is that, all right, if I have 2 comma 3, again, there's no y value, so I get 2 minus 1, which is a positive 1. And so then that's going to be positive 1 right there. What you do to create a slope field is you keep putting in all of these points, negative 2 comma 2, negative 1 comma 2, 0 comma 2, and you just keep putting in the slope at all of these points. What kind of helps is looking for patterns, and then you fill them all in. So we're going to speed up the video here. I'm going to fill in all of these slopes.
So I travel and I roam till I find that, but I'm full of adventure, so I wander and I venture, and it's safe to say that really I don't mind that. I book a flight to try to figure where my mind's at.
And that right here, what we've just created, that is the slope field. So again, this is the possibilities of all the solutions to this differential, dy dx equals x minus 1. We don't have an initial point, but say in case we did have an initial point, then we would kind of have the general idea of what this function would look like. So I could say, okay, look at this parabola, and I know it's going to be a parabola because we have x, so when we take the integral, we're going to get like x squared over 2 right there. And so we could have a parabola here, we could have a parabola there, and we kind of get this idea of what each of these shapes should end up looking like. So what I want you guys to do is, in this next one, we're going to do the exact same thing. Grab points here for 0 or negative 2 comma 3, and just keep going across all the rows. And what's going to happen is you're going to substitute in the x and the y. So for example, if I have the point negative 2 comma 3, well then this is going to be negative 2 minus 3 in for the x and the y, which comes out to be negative 5. So very steep negative slope, something like that. And it doesn't need to be perfect, it's just a little hash mark. And I want you to fill out this entire slope field, and we'll come back in a second. All right, and that right there is going to be our slope field in this case. So this is all you have to do. You don't, on the AP Examine the free response question, go ahead and look up some previous year's free response questions when slope fields show up. And what you're gonna notice is you only have to do like 6, 7, 8, 9 points. You don't have to do like 20 points that we have to do here. But you do wanna keep in mind how to do this. You're taking in the points and you're substituting into the differential. So what we're gonna do on this next one is we're given this differential dy dx equals x minus 1. We already have the differential drawn over here. So you're able to see, okay, what does this look like already? And a common free response question is to do this after you've already created the slope field. What we want to do is to sketch the solution curve through the point 1 comma negative 1. So we want to go straight through this point here. And as I'm looking at dy dx equals x minus 1, and I want to think about the original equation, well, the original equation for this, and this is just a sketch, so we're not going to do anything exact, but this is the original equation is going to have x squared over 2. Because we know we're going from a linear equation up to a quadratic equation. So we know we need to have a parabola, and it looks like we're gonna have a parabola from all of these shapes here, okay? But we just need our sketch to actually go through that point. So in order to do that is I kind of follow these slopes and I create a sketch of what this parabola would be as long as it goes to that point 1 comma negative 1. And that right there is going to be my sketch. Now, sure, you might have done something a little bit differently, but as long as it's pretty darn close and it goes to that point, it's parabolic in a shape, you can see like, okay, this is maybe perhaps a little bit wider. Maybe this will match it a little bit better, but this is all you have to do is create a sketch of what your function can look like. So now that we know what slope fields look like, we're going to continue to look at them a little bit more about how do you match these up. So there's some matching going on. I'm going to show you guys how to do those activities, and then finally we're going to do a free response question at the end of the next video. So stay tuned for that. Of course, if you need to check some of your answers, you're not sure how I got some of these values, go ahead and reach out to me, put it in the comments below so I can help you out. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.
It never gets me
we go way back. All the situations, circumstances, still we don't mind. Steady going on, I dance around the street lights. Hey, I know every street sign, hanging around the block. Like if you are my friend, then you are welcome any moment.